Now the formula for Spearman's rank correlation, the correlation between two variables R, X, Y, Spearman's rank correlation is 1 minus 6 summation d square by n into n square minus 1. This is the formula for Spearman's rank correlation. Now what is D? D is called the difference of ranks. You have done this in your tuition?
No, sir.
D is called the difference of ranks and n is the total number of observations. Okay, let us take an example and see how this formula is used. Problem. Question is, the marks obtained by the students in physics and mathematics are given below. Given below. So this table is given to you. The marks in physics, and marks in mathematics. So these observation marks in physics. These are the marks in mathematics. Okay, these two. Now in sphere here, if you see how many observations are there, there are 9 observations. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9 observations are there. Okay, so n, the value of n here in this formula is 9. So here n is equal to 9. Now we shall proceed. First, we make the tables. You require 6 columns for these. The first column will be for marks in physics. Let us call it X. Next column will be for marks in mathematics. Let's call it Y. Next column will be for ranks. Rank of X. Next column will be for rank of Y. Okay. Next column will be for difference of ranks. D. If I call this as say R1, if I call this an R2, then the difference of ranks will be R1 minus R2 or R2 minus R1 also. Any way you can take. And D square, the square. Why did I put a column for D square? Because in the formula I see a sigma D square. Yes, Devanjan, why are you late? Again, always 10 minutes, 15 minutes late.
So 3 minutes late, sir.
Why 3 minutes? Class started at.
Network issue, sir. I couldn't join. I just
No,
now,
but that is
just now.
regular. No, that is something very regular. No. So network issue
Not
is
sir.
not as regular.
After you said I come on time, just 1 or 2 minutes late.
Just for 2 weeks you have been on time, but before that you were
Ah,
always
just
late.
after you said. Okay, sir.
47, 17, 10, 43, 9, 6 and 28. So that is your X. Now we write Y. See, it is always better if you can arrange one of these, either X or Y, in ascending order and then write the corresponding. Okay. I'll show you in the next example. It is always better whether either you arrange this or you arrange this in ascending order and then write the corresponding observations. 30, 33, 45, 23, 8, 49, 12, 4 and 31. Okay, these. Next, we assign the ranks. Now here you have to be a little careful in assigning the ranks. How do you assign the ranks? See, rank of X is there. Look at the values of X. Okay. If you see these values of X, which one is the highest value? The highest value among X is 47. So you give it a rank 1. You understand this? Yes, do I have an audience?
Yes, sir.
Next
Got it.
highest rank is, second highest rank is 43. So you give it a rank 2. Okay. Next highest rank is 35. So you give it a rank 3.
3.
Okay. The next highest rank is 28. So you give it a rank 4. The next highest rank is 23. So you give it a rank 5. The next highest rank is 17. So you give it a rank 6. The next highest rank is 10. So you give it a rank 7. Okay. The next highest is 9. So you give it a rank 8. The next highest is 6. So you give it a rank 9. Okay. So you have assigned the rank. Similarly, you assign the ranks for R2 also. Okay. So the highest rank here in R2 is 49. So you give this a rank 1. The next highest rank, the next highest marks is 45 in Y. So you give it a rank 2. The next highest rank is 33. So you give this 3. The next highest is 31. So you give it a rank 4. The next highest rank in the Y series is 30. So you give it a rank 5. The next highest is 23 in the Y series. So you give it a rank 6. The next highest rank is 12 in the Y series. So you give it a rank 7. The next highest rank is 8 in the Y series. So you give it a rank 8. Next highest rank is 9 in the Y series. So you give it a rank 9. Fine. Once we have assigned the ranks, now we calculate the difference of the ranks. D is equal to R1 minus R2. So this is 3 minus 5, which is minus 1. This is 5 minus 3, which is 2. And you go on like this. 1 minus 2 is equal to minus 1. This is 0. 7 minus 8 is minus 1. 2 minus 1 is 1. 8 minus 7, 1. 9 minus 9, 0. 4 minus 4 is 0. Now you write the squares. D square minus 1 square is, right, minus 1 square is 1. 2 square is 4. Again, minus 1 square is 1. This is 0. Similarly, minus 1 square is again 1. 1, 1, 0, 0. Okay. So now what you do is, you add up the column for D square. This is summation D square. Summation D square, you add up, you get 12. Okay, summation D square. Now we'll use Spearman's rank correlation. Therefore, Spearman's rank correlation R, we use the formula. Devanjan, you were not there when I gave this formula. 1 minus 6 sigma D square by n into n square minus 1. So here what are the values? Here n is 9, number of observations. Summation D square we have found as 12. Just put the values. Hence Rxy is equal to 1 minus 6 into 12 divided by n into n square minus 1. That is 1 minus 6 into 12 divided by 9 into 80. Okay, so this you cancel certain things. 3 2, 3 3, 3 1, 3 4, 4 1, 4 20, 1 10, which is 1 minus 1 by 10. Take the LCM, you get 9 by 10, which is 0.9. This is the correlation. Now what do you mean by this correlation 0.9? Can you interpret this correlation for me? Yesterday I taught you correlation. Sumit Gupta, are you there?
Yes, yes, sir,
Interpret
yes,
this
sir.
correlation for me. 0.9. What does this correlation mean? 0.9.
So,
It means R has a very high positive value. And you already know, I don't know whether I had mentioned this, but still, if I have not, then let me just mention that the value of the correlation coefficient between two variables x and y always lies between minus 1 and plus 1. And when r is equal to minus 1, rxy is equal to minus 1, that means we say that x and y have a strong negative correlation, have a perfectly negative correlation, perfectly negative correlation, right? When rxy is equal to plus 1, we say x and y have
Perfectly positive correlation.
perfectly positive correlation. So now when r is equal to 0.9, it is very close to plus 1, right? So
Mm,
we say
yes.
in the above problem, rxy is equal to 0.9 shows a strong positive correlation. Strong because it is very close to 1. It is not perfect, but it is very strong. Shows a very strong positive correlation between marks in physics and marks in mathematics. And marks in mathematics. That means students who are good in physics are also good in mathematics, may have a very high chance of being good in mathematics. And students who are good in mathematics have a very high chance of being good in physics. That is what it means. Clear?
Yes.
That is what the interpretation is. Now, the main thing here is here, if you see in this problem, all the ranks that I have given are different, isn't it? See, I have the first rank 45, the second, sorry, 47. See, rank 1 I have given, this is for 47. The rank 2 that I have given, this is for 43. All the ranks are unique. But what if I had an observation like, say, instead of 23, if I had a 43, then what will happen? Will I give a 2 here also? This is called the case of tied ranks. That is, if two or more observations are equal, then what rank should I give? Okay, so let's see with the help of a problem here. Okay, so question is, find out, find uh, the correlation coefficient, find Spearman's rank correlation between x and y, between x and y for the following observations. And what are the observations? Let's see. So for x, you have, for x, for y. Okay. Yes. Let's write the observations. Oh, there are 480. Sorry. Oh, sorry. Let's try with this. X series observations. Let's say this 2.7, 2.5, 2.7, 2.5, 2.5, 2.7, 3.5, 4.9, 5.4, 5.4. I have 3.8. So you have 11 observations. 11. And the Y series observations 30, 27, 50, 76, 37, 14, 34, 75, 60, 121, 74. Yes. This is your question. For this question again, we will assign ranks. So first you have the first column will be for your X series observations. This is your X. This is your Y. Next is rank of X. Rank of Y. Let's say R1. Rank of Y is R2. Difference of the ranks. And you have square of the difference. A square. Let us list the observations first. Observations 2.7, 2.5, 2.7, 2.5, 2.5, 2.7, 3.5, 4.9, 5.4, 5.4, then you have 3.8. These are the X series observations. I told you try to arrange in ascending order as much as possible. If you can, either X or Y. Corresponding Y are 30, 27, 50, 76, 37, 14, 34, 75, 60, and you have 121, 74. That's it. Now we shall assign our ranks. So let's see. Tied ranks. What happens? What should be the rank? What should be the first rank? Which one is the highest observation? If you see here, the highest observation is 5.4, but there are two 5.4s, right? So which one should I give 1 and which one should I give 2? Yes, can you hear me?
Yes, sir.
Which one should I give 1? Which one should I give 2?
Sir, 121 down one, sir.
Actually, you can give anyone. You can give this one and this 2, or you can give this 2, this one also. But the problem is we cannot write it here. Where do we write? So what you do is, since the rank of one of them will be 1 and one of them will be 2, so what we do is we take the average rank, 1 plus 2 by 2, which is how much? 1.5. So what you do here is you write 1.5 here and you give a rank of 1.5 here. You understood what I'm trying to say? You understand what I'm trying to say?
Yes, sir.
Okay. So next rank 2, 1 and 2 I have already exhausted. Okay. 1 and 2 I have already exhausted here, right? The ranks. That means 1 and 2 I cannot use. Now I'll start with the rank 3. So which one is the next highest after 5.4? If you see, the next highest
4.9.
is 4.9. So what I'll do is I'll give a rank 3 to 4.9. Okay. The next highest is 3.8. So I'll give a rank 4 to 3.8. Okay. The next highest is 3.5. So I'll give a rank of 5 here. The next highest must be given a rank 6. If you see, the next highest,
2.7. 6
yes,
plus 7 plus 8 by 2.
2.7, 2.7, right? But there are two 2.7s. So 6, give this a rank 6, give this a rank 7. But take the average of the rank, 6 plus 7 divided by 2, which is 6 point. Um,
The down is the one
there's
is
one
down
more.
also.
There's one more. Okay, there's one more. 8. So 6 plus 7 plus 8 divided by 3. So this is 7, right? 21 divided by 3 is 7. So I give a rank of 7 to this, 7 to this, and 7 to this. So what? How many ranks have I exhausted here? 6, 7, and 8 ranks I have exhausted. That means the next rank that I must assign must be 9. So what is the next highest number after 2.7?
2.5.
2.5. But how many 2.5s can you see? You can see one 2.5
3,
here,
3.
one 2.5 here, and one 2.5 here. Let us say this is 9, this is 10, and this is 11. Again, take the average, 9 plus 10 plus 11 divided by 3. Okay, so this is 21, 21 and 30. So this is 10. The average comes to 10. That means we'll assign the rank 10 here, we'll assign the rank 10 here, and we'll assign the rank 10 here. Understood? How to deal with tied ranks? Any questions on tied ranks? Mr. Devanjan, any question on tied ranks?
No, sir.
Fine. Similarly, we do for the Y series. Okay. I'll just write the ranks. Y does not have any tied ranks, I think. These are the ranks. Y does not have any tied ranks. Okay. Now we take the difference of the ranks. 7 minus 9 is minus 2.
Minus 2,
This is
0,
0,
1,
1, 8,
8,
3,
3,
minus 4,
minus 4,
minus
minus
3,
3, 0,
0, and minus
1,
3.5.
oh, sorry, minus 3.5.
This is 0.5 and this is 0.
Minus 0.540.
And then you square the ranks. Minus 2 whole square is 4, 0, 1, 64, 9, 16, 9, 0. 3.5 square is how much? 112.25. And this is 0.25. And then this is 0. And now you add this up. Summation d square. If you add all these, you will get 115.5. Okay. So now we'll put it. But there is something called as a, because of the tied rank, there is something called as a correction factor. And the formula for correction factor, when you have tied ranks, we apply this correction factor. Correction factor is equal to 1 by 12 times m cube minus m, where m is the number of tied ranks. Number of tied ranks. Okay. So how many tied ranks? First of all, you have two tied ranks here. So what is the correction factor? Correction factor is equal to 1 by 12 times. You have m is equal to, first you have two tied ranks, so put m is equal to 2. 2 cube minus 2, right? Next, how many tied ranks do you have? Next, you have three tied ranks. This,
3, sir.
this, and this, right? Three tied ranks you have. So plus 1 by 12 times 3 cube minus 3. You also have another three tied ranks. What are those tied ranks? 2.5, 2.5, 2.5. Another three tied ranks. So again, plus 1 by 12 times 3 cube minus 3. Understood? Tied ranks?
Yes, sir.
If in y you do not have any tied ranks, because if in y you had any tied ranks, then you would have again added another 1 by 12 times whatever. Understood? But in y, luckily you don't have any tied ranks. Is this very clear to you? M is the number of tied ranks in each
Yes,
series.
yes, sir.
For we had found three tied ranks in the X series. There are no tied ranks in the Y series. That is why there are no M factors for correction factors for your Y series. Or whatever we had, this is for X series, X series, X series. Right? If in the Y series you had, you would have had to add further 1 by 12 times whatever. Okay. However many tied ranks are there. So therefore, now if you add up these, you'll get 4.5. This is your correction factor. Now when calculating Spearman's rank correlation, or let's say corrected value of sigma d square, corrected value of sigma d square is equal to, now what do we do with this 4.5? What we do is, with sigma d square that we have got here, okay, we add this correction factor. This is 115.5 plus 4.5. So you get this at how much? 120, right? So now therefore Spearman's rank correlation is equal to 1 minus 6 corrected sigma d square divided by n into n square minus 1. That's it. You put the values. 1 minus corrected value of sigma d square is 120. And how many observations are there? There are, I think, 9 observations here. 9 observations, isn't it? See, here n is equal
11
to
observations.
11. 1, 2, 3, 6, 7, 8, 9, 10, 11. 11 observations. So we put the value here. N into n square minus 1. That's it. If you calculate this, it will come to 0.46. Okay, so what kind of a correlation is this? 0.46.
0.5 middle.
It is a fairly average correlation, not a
Yes.
very
Mm,
strong correlation, not a very weak correlation also. It is a fairly average correlation. Okay, fairly average positive correlation, not a negative correlation. Because if it was negative, you got a minus sign there. Okay, so I stop here for today.